Okay, this is section 2, which is graphing linear equations. And we're going to look at y equals mx plus b again, because that's our easiest way to graph things. The number in front of the x tells you your slope, which is rise over run. And the number without the x is your y-intercept. We've put plus b here. If it says negative b, then it just means that the y-intercept is negative. So graph the equation y equals negative 1/3 x plus 3. So first of all, I'm looking for that y-intercept, the part that doesn't have the x with it, as long as it starts with y equals, as it does here. So I'm going to start from 3 on the y-axis. And just remember why you're graphing. If it starts with y equals, you're starting on the y-axis. If it starts with x equals, then you're going to start graphing from the x-axis. So negative 1/3, when we have the negative in the middle here, just remember this only applies to the top number here. So if it applied to both numbers, then actually it would cancel out and it would just be a positive. So when we see negative 1/3 like this, it means negative 1/3. So first I'm doing a rise, but as it's negative, that means I'm going to do the opposite. So I'm actually going to fall 1 square. I'm going to go down 1 square. And then the run is to the right. So 1, 2, 3. It says be sure to plot at least 2 points. That's just so you can draw a line from it. If you can, just keep going a little bit. 1, down 1, and then go across 3. Down 1, and then go across 3. And the reason I recommend this is as you're checking your multiple choice answers, you can actually look now, where does it go through on the x-axis? So this goes through 5, 6, 7, 8, 9. So if your graph goes through 9 on the axis, then you can kind of confirm that that is going to be the correct answer. Normally when we use our SOL, once you've clicked 2 points, it will normally just draw the line through it to help you do that. What was the x-intercept? Well, there you go. Sometimes they will ask that question, so we can go ahead and fill it in straight away. Y equals 2x minus 6, so it's in slope-intercept form. So the number without the x, make sure you're looking at the sign in front as well. That's where we start from on the y-axis, because it starts with y equals. Now, my slope of 2, this time I only have a single number, whereas I had a fraction on the last question. Now, I always want a fraction because I want to be able to do rise over run. So what we do is we just put every whole number over 1. And the reason that works, of course, is 2 divided by 1 is still 2. So when you have that single number, just remember you're going to count across 1 square to the right when you do that. Oops. There we go. So I go up 2 squares, and then I go right 1 square. I go up 2 squares, I go right 1 square. I go up 2, and then I go right 1. And that should be enough for us to come up with a better line for what this actually looks like. Let's look back at the graph in question 9. What is the x-intercept? Now, specifically, the intercepts is really part 3, but it's just so we can actually do a little bit of extra practice on that. So I can see it goes through 3 on the x-axis. So when I'm writing my coordinate, remember the first number is the x value. So for this one, I would want 3 and 0. 0, 3 would possibly be a good multiple choice answer. See, and they included that here as well. So I'm going to include that. And I'm ready for my next question. Y equals negative 3x. Now this time it starts with y equals, so we know this is slope-intercept. I can see the slope is negative 3, but there's no number at the end here. So that actually means for my y-intercept that I'm actually, as there's nothing there, I am going to start from 0. My slope of negative 3, just like the last problem, it's just a single number. So I'm going to write it over 1. And as I'm counting my squares out, that means I'm going to go down 3 and then across 1. Down 3 and across 1. And then I should be able to just join this up. Something like that. This time, once again, starts with y equals x plus 3. So that means I'm going to start from 3 on the y-axis. And this time there's no number in front of the x, which means that, remember, x can be written as 1x. So actually my slope this time is 1. Now, once again, as it's a single number, if it's not a fraction, we're going to put 1 on the denominator so that it is a fraction. 1 over 1 is just 1. That's why this works. Now, as this is a positive number for the numerator this time, that means I'm going to count up 1 square. And then right 1 square because of this 1 on the bottom here. Up 1, right 1, up 1, right 1, and so on. And then we can draw this back, and that should be good. Y equals negative x. So once again, slope-intercept form, so it starts with y equals. No number on the end, so that means that I'm going to start from 0. No number in front of the x, but there's a negative sign, so I know this is negative 1 this time, and make it into a fraction for rise over run. So a rise of negative 1 means I go down 1, right one, down one, right one, down one, right one, and so on. As you're doing this, you can see that it's negative slope because it says negative x. Just make sure that this line that you are drawing is negative just to confirm that you've done this the correct way. And you can see that that's true for this. Now, there are some special ones. We talked about Hoy and Vux in the first part of the video for 2.1. Hoy, for horizontal lines, that's where we're going to get the H from. The slope is 0, so it's not really an O, it's more of a 0. Your equation is y equals. And for vertical lines, we use the word Vux. V for vertical, slope is U for undefined, and the equation starts with x equals, and we'll use those to do these ones. So when I see x equals 3, I'm immediately thinking of the word Vux. Now, we use Hoy and Vux also when it's just one variable. So notice here, there's only one letter in this equation. So as it's x, I'm thinking of the word Vux. I know it's a vertical line, and this time I'm going to start from 3, but on the x-axis. So start there, plot any point that you like that's on the line, and that should be enough for you to actually draw in the vertical line here. Fairly quick to do once we know what we're looking for. Although it starts with y equals, this is not really slope-intercept because there's only one letter here. So I'm thinking for this question of Hoy. So I'm going to start from 2, but this time on the y-axis because it says y equals. And I want a horizontal line, so I'm just going to put a line, a dot that's to the side of it. And then I can join that one up as well. So identify the graph. As this is a horizontal line, I know this is Hoy. So H-O-Y, so I know I'm looking at y, and notice it goes through -2 on the y-axis, so y equals -2. Really easy to check. Vertical line goes through 1 on the x-axis, so x equals 1. That Vux would help for this one as well, but also the fact it goes through 1 on the x-axis is also useful for this. Now, if we're looking at graphs that aren't in standard form, we can make them into standard form, and we did some of that in 2.1 as well, and that makes it easier for us to graph it. So if I do go ahead and rearrange this, I want to bring my x's to the right-hand side. Remember, you can't work out 8 minus 2x. It's not 6x. It's just 8 minus 2x. And then I don't want to know 4y. I just want to know y, so I divide everything by 4. 8 over 4 is 2, and if you simplify -2/4, you would find out it's -1/2. Then you can use those same tricks we just used before. The number without the x is where you start from on the y-axis, and the slope would be -1/2, which means we go down 1, and then right 2 squares. Now, there is another option that you can use for this. You can also use x and y-intercepts. So the thing about x-intercepts is they occur when y equals 0. So effectively, this disappears, and we just have 2x equals 8. And then you can set you can set x equal to 0 to find the y-intercepts, which would give you 4y equals 8. So you kind of just cover up the x part, look what you got, cover up the y part, look what you got, and then you solve those two equations. So just one-step equations, but the x would equal 4. So remember, that's the x-intercept, and the y would equal 2, and therefore that's the y-intercept. And then you can just plot those 2 points, plot 2 on the y-axis, plot 4 on the x-axis, and then just use that line to join them up. So there's a couple of different ways. I personally like this method when I can see that these two numbers divide into this number. When that doesn't happen, I personally prefer, if that doesn't happen, I would use the first method. So 2x plus 3y equals 12. I'm going to do it both ways, but I would personally do the second one for this if it was me doing this question. So I'm going to start, whichever method you do, you're still going to need to write something. So I'm going to start by writing out the equation. I'm going to take away 2x from both sides, because I'm trying to move my terms away from the y, because I want it to say y equals. So that would cancel. 3y equals 12 minus 2x. Remember, it's just 12 minus 2x. Don't try to put in 10x. These are not like terms. And then instead of 3y, I just want y. So I'm going to divide each term by 3. Divide by 3. Divide by 3. And 12 divided by 3 is 4. And you can check -2/3 does not actually simplify. So that is actually the answer. So if I graph this, it starts from 4. And then the slope is, it goes down 2 and across 3. Down 2 and across 3. And I'm not going to use a line for this one. I'm just going to leave it right there for now. But I am going to go back and look at this. What if we did this by x and y intercepts? Well, if I set x equal to 0, then I just get positive 3y equals 12. So 3y equals 12. And then if I divide both sides by 3, hopefully you would agree it's 4, and also because 3 times 4 is 12. So the y-intercept is 4, and you can see we actually already plotted that earlier, so we know we're looking good so far. Now, if I do the other way around, if I set the y is equal to 0, this becomes 0, and I just get left with 2x equals 12. And then if I try and work this out, 12 divided by 2 is 6, and also 2 times 6 is obviously 12. We know our times tables, these are kind of quick to do. So 6 on the axis, and notice this time, if I join up from my 6 to my 4, hopefully you can see that it passes through that point that we did when we did our slope here. So we get the same answer whichever way we choose to do this question. I didn't use my Desmos calculator because I simplified in my head, but you can use that if you need to. Same thing, I will do it both ways. So 2x plus 4y, oops, I put the wrong question there, equals -4. So I'm going to try and make it say y equals. So I'm going to need to bring my x's to the other side. So instead of positive 2x, I'm going to do -2x. That cancels. 4y equals -4 minus 2x. Remember, it's not -6x. These are not like terms. And then I can divide both sides by 4. Make sure you divide each of the terms by 4. And if I use my calculator for this, -4 divided by 4 is -1. And -2/4 simplifies into -1/2 x. Now, if I come to graph this as it starts with y equals now, the number without the x is where I start from on the y-axis. So I'll start from -1. And -1/2, that's my slope because it's got the x next to it. I know that means I go down 1 and across 2. If I continued, I could do it a few more times, down 1, across 2, and then I could join it up. Now I'm going to leave it just for a second because we're going to check using the other method. So if I set my x's to 0, that means the x's disappear. And I just get 4y equals -4. And if I divide both sides by 4, I would get y equals -1. And as you can see, that was exactly what we had a second ago because we already plotted it. Now, if I do the same for the y's, if I set y equal to 0, this term disappears. I just get 2x equals -4. And then if we divide both sides by 2, you'll get the answer x equals -2. And I'm just going to put a circle where I would put it. But just to show you, if I connect up my x-intercept to my y-intercept, oops, that didn't quite work as I was hoping. That's supposed to be the line tool, but that doesn't seem to be working particularly well. Oh, that line tool. Okay, there, it goes through there. But can you see if I extend this line, all those points do lie together. So you get the same line whichever way you do this, but it depends which way you prefer to do it. And that concludes the video for graphing. So 3 kind of real questions in there. One is when it's in slope-intercept form, y equals, look for the value without the x to tell you where to start from on the y-axis, and then use the value with the x to tell you what the slope is. Second one, the horizontal and vertical lines, use Hoy and Vux to try and help you figure out which is which. And the third one is if it doesn't start with y equals, make it say y equals, and then you can graph using the first method, or use the method of using x and y intercepts, set x equal to 0 and solve, and then set y equal to 0 and solve, and then plot 2 points that way, whichever works best for you. That's the end of this part of the video. There will be an extra video for part 3. And as you can see here, that's going to be specifically on finding x and y intercepts.